Complex numbers, day 2. First question for this one is a little weird. All right, it kind of more so goes along with the concept of the complex numbers versus the real number part. More than anything, you're really doing. Okay, so the question asks: find the values of x and y that makes the following true. So on the left side, you have 3x minus 5 plus the quantity in parentheses of y minus 3I equals 7 plus 6I. Okay? Now, the right side here, the 7 plus 6I part, that's a complex number. Right? Plain as day. Real part, imaginary part, you have a complex number. Okay? And what it's asking you, what this question wants to know, is what number do you need to put in for x, and what number do you need to put in for y that will make this left side be 7 plus 6i. So you're not really too concerned about the I in this case, because all you really need to do is figure out this real part and this real part need to be equal. So 3x minus 5 needs to equal 7.
Why don't you worry about the other part?
I'm getting there. Okay? And then your imaginary part, just the part now, you have y minus 3 equals 6.
What about that?
Okay? That's what I'm getting to. It's all good. You don't care about the I because you're just putting the parts. Okay? You have I have the real part in blue. I have the imaginary part in green. So all you care about is finding what value you put in to y to make the left-hand side's imaginary part equal the right-hand side's imaginary part. Okay? Make sense? So you don't care that it is imaginary. You want to know what that value is that you put in here. Okay? After you do that, it's 2 easy solves. All right, everybody see that? Okay, so just add 5 to 7, which gives you 12. So 3x equals 12. Whoops. X equals 4. Okay, so now check it. Plug 4 in here. What's 4 times 3? 12. It's 12 minus 5. 7. So see how your real part equals 7 over here now?
Yeah.
Okay. And on the green one, you add 3, so you get y equals
9.
So whenever there's like imaginary numbers that those like aren't even really a part of the equation, like you really want to looking at the
You're looking at the number that's attached to it. In this case, yes. Okay, whenever you have an equation of 2 complex numbers like this, and they're saying find the value that makes this statement true, that's all you do. You just take the part. You don't worry that it is imaginary, because both of these are with the imaginary part. You want to know what number you put in for y. That when you subtract 3 off of it, you get 6. Okay, makes sense. Because if you plug both of them back in now, you get 3 times 4 minus 5 plus 9 minus 3 I. We already said this is 7, and this is plus, and that we cleaned that up to be 6I. So you see how 7 plus 6I equals 7 plus 6I.
7 plus 6, that's the answer?
Yep. Well, 4 and 9 are the answers. But that's your check.
That's pretty good.
There we got the setup good. So subtract 2x, and then subtract 1, so you get 3x equals negative 3, so x equals negative 1. And then your other end, you got, let's see, y equals negative 9.
Would you like to?
I would like to, thank you. Yes. Appreciate it, thanks.
Looking out for you.
Alright, so here's where...
I hate word problems so much.
That's okay. All right, here is kind of where the only like real world application of imaginary numbers come into play. All right, as far as word problems go, they have to do with electricity. Okay. Now, whenever you have these problems, it's going to be fairly easy, fairly straightforward. The only difference is this, and it's kind of like what we talked about yesterday. There's this thing in electricity that's called impedance. All right, and it's represented by the capital letter I. All right, as you can read. All right, in an AC circuit, the voltage V, current C, and impedance I are related by the formula V equals CI. Okay. Now, for that being said, to avoid confusion, as if these aren't confusing enough, instead of using I down here, they use J. Same thing, though. Okay? Same thing. So it's your choice. You can either keep them I's or keep them J's, rather, or you can change it back to I's. Totally up to you. Okay? It doesn't matter. But the word problem to it is actually fairly simple once you read it. Okay? So in an AC circuit, the voltage V, current C, and impedance I are related by the formula V equals CI. Find the voltage, so we're looking for V, in a circuit with current of 2 plus 4J amps and impedance of 9 minus 3J ohms. So we don't know voltage, we know C, we know I. So all you do is FOIL it out. That's right. So you got V equals.
What is that?
J is just acting like I. So I'm going to actually change it right now. So 2 plus 4I times 9 minus 3I. Okay. And if you want to leave them as J's, that's fine. The same rules apply. But honestly, in my opinion, once you get them plugged in and there's no I in the formula, I would just switch them back to I's. Okay. And then you go FOIL. So 2 times 9 is 18, minus 6I, plus 36I, minus 12I squared. Clean it up from there. All right, change your I squareds to -1, so you have 18 minus 6I plus 36I plus 12, and then do your like terms. So 18 plus 12 gives you 30, -6 plus 36 plus 30I. This kind of leads into the last topic for the day. All right, like I said, second day is really more so about the little things like the first two. This is kind of one of the bigger ones. All right, this concept of complex conjugates. This goes into what we're going to do next, which is divide. Okay, it's the only thing we haven't done yet with the complex numbers is divide them. Complex conjugates are two complex numbers that are of the form a plus bi and a minus bi. So the only thing different between the two is what? The sign, yeah, signs in the middle. One's a plus, one's a minus. Okay. Now here's the slick part. The product of complex conjugates is always a real number. So you're going to take, here's the last part where this gets weird. You can take two complex numbers, bless you, FOIL them out, and it ends up in a real number. Okay? The first one we do after this doesn't use that. We will the next one, though. All right? And then you can use this to help simplify the quotient of two complex numbers. Because that has to do a lot with square roots. Okay?
Draw stuff for us.
Yeah. Okay, now here's where this comes into play, all right? On what and how you're going to divide these. You may remember this, you may not, so I'm going to just kind of throw it out there. Whenever we did square roots, you could not have square roots in the denominators. Remember that? Yeah. Okay, you had to do what was called rationalize. Okay? Kind of the same thing with imaginaries. You can't have imaginaries in denominators either because those come from square roots. It's essentially the same thing. All right? So you need to work it through and do some algebra to it so that you don't have imaginaries in your denominator anymore. One like this is real easy. And it's because you only have what's called a monomial in the denominator, one term. Okay, this one's super easy. All you do, like how you'd multiply by a square root top and bottom, you're going to multiply this top and bottom by an I. Okay, which means the top, you're going to distribute an I through.
So it'd be 3.
No.
Yeah.
So 4I plus I squared.
Oh.
Over 5I squared.
So that would be 4.
Yeah.
So 5's actually.
I have a question.
What's up?
No.
So you said you
Oh,
can't have an I, or
5
you
minus
can't
1.
have an imaginary number in your
Denominator.
in the
I squared is
bottom,
Right.
minus 1,
but
yeah.
isn't there technically still one in the?
Yes.
Because that,
Right. So now, here we go. So now you clean up your I squares. I squared is what?
Minus 1.
Negative 1. All right, so you have on top 4I
Minus 1.
minus 1 over 5 times negative 1 to give you negative 5. 4 times negative 1 times.
Oh, I didn't
So you
Okay.
just have to get to I squared or I
Yeah.
full.
Right, and you want to keep it small as possible, so you just do it times I top and bottom, make it I squared, and be done. Okay, now, I am going to be picky with you guys. You guys are juniors now, I can. Okay? Negatives and denominators are not good things. Okay, it's not clean, it's not proper. So clean that up, and you'll have to do this every time with these. Okay? Times top and bottom by negative 1. Meaning all you have to do is change every sign. So 1 minus 4I over 5. Okay. Denominators change now. Everybody see that?
Yeah.
Okay, so we've gone from having a monomial down here. Anybody know what this is called?
Binomial.
Binomial. Very good, 10, yes.
Wait, don't you just do the same thing?
No, you don't. Because remember what your goal is here. Okay? Your goal is to get rid of the I in the denominator, right?
Yeah.
So if you would to just multiply top and bottom by an I, top would become 2I squared. Hey, cool. You would have 6I squared down here. Hey, cool. But this 3 would become what?
3i.
3I.
And you don't want that.
Correct. Ms. Harris? Not quite.
Do we do 3 over 3?
Mm.
Times 6?
I was gonna say
Six
times
I.
6I.
Hold up, what?
Do we multiply 2 times 6i, so 3 over 3, and then minus 6i over minus 6i?
Not quite. You guys are close. Almost. Almost.
3 plus 6i.
Almost. Really close.
Minus 6i.
Atta girl, Megan McKenzie.
Nice. What?
Because then what are these two? 3 plus 6i and 3 minus 6i are what you just wrote down, which is? About 5 minutes ago?
A minus b.
No.
Oh, A plus
No.
BI.
That word. Those words. That definition.
Complex conjugation.
Complex conjugates. Saying Spanish.
I was going to say conjugation.
I know,
So I
that's-
stopped at
yeah.
gay. Conjugate.
Okay? Complex conjugates. Now, remember what that definition said. They are of the form A plus BI, A minus BI. Now, obviously, A and B are going to be numbers. So 3 plus 6i, 3 minus 6i.
Right.
Okay?
Do you just.
And now, it also said in that definition that the product of those two is going to be a what? What kind of number? A real number. Which means it's not imaginary,
So
which
there's no
means,
I.
exactly, you get your I out of your denominator. Okay? So the top, here's where this gets a little messy and you kind of have to watch your work, okay? Your top, you're going to multiply the numerators together, multiply the denominators together. Alright, so I'm going to write it like this just this one time. You have 2i times 3 minus 6i on top. On the bottom you have 3 plus 6i. 3 minus 6i.
So do you have to foil the bottom?
And you have to foil the bottom, right. Okay. Now, real quick, just so it's, since you see it like this, you
Oh,
I
you
shouldn't
can't
say
cancel
I
those
shouldn't
out?
say can't. You can cancel these out,
But then you're just going to get
but you're back to where you started.
Exactly.
Okay? So don't instincts go cancel these even though you can, because then you do yourself no good. So you distribute the top, you foil the bottom. So you get 6i minus 12 I squared all over 9 minus 18I plus 18I minus 36 I squared.
I like that you talk what you write down because I didn't have to look up once that whole time when I just read it.
You're welcome. I do what I can. I try to teach well. Now go through, clean up your I squares, combine your like terms. So in your numerator, you have that I squared in front of negative 12 to make it positive now. So I'm going to flip it again. Okay, that's just my habit, guys. Sorry if you don't like it.
That cancels out the.
Hang. Shh. So 12 plus 6I here. Negative 36I squared is going to become positive 36, right? Okay. Not, hang tight. Positive 36 plus 9 becomes what? 45.
Wait, what? That's it.
36I squared. See how it's negative here?
Yeah.
I squared is negative 1.
So 36.
So positive 36 plus this
Plus
9.
9.
45. Okay? The
Also,
middle.
after you did, you have to combine them.
Right. I'm killing two birds here. Negative 18I plus 18I becomes? 0. So see how your conjugate, 3 plus 6I, 3 minus 6I, the middle two where the single I powers would be, have coefficients that cancel each other out. The only way that's going to happen is with this conjugate up here. Okay? So if you see a setup like this, you do the opposite. And if this was a minus, your in red here would be a plus. Okay? Okay? Whatever the opposite would be. All right, Mr. Galloway.
Can you just leave the top 6I plus 12?
You can.
He said
Is there a reason? Is there a reason?
Now, something that I'm not sure if we all remember or have done or what. Okay? I didn't circle it yet.
Yeah, I haven't either. It's not reduced.
Good job, Wags.
Oh.
What can you reduce it by?
3.
3. Good. Good. Reduce it by 3.
15.
Wait, do you reduce the I too?
The coefficient in front of I.
So like 6 would go on 2.
Right.
So it'd be 4 plus 2I over 15.
There you go. Then you're done. Okay? Remember, it has to be able to do by all 3. Okay? If it's just 12 and 45 that reduce, and this was like a 7 over here, you don't do it. Then you're done. But 12, 45, and 6, they all reduce by 3. Okay, top one. 3 plus 5I is what they give you. Come on, there we go. So times by 3 minus 5I. 3 minus 5I. Now, as you get better with these, okay, I'm going to start skipping some stuff. Okay, first thing I'm going to skip is rewriting them together. All right, I'm just going to start putting parentheses around them, like this, and like this. Okay. So the numerator you were distributing, so we have negative 6I plus 10I squared all over 3 times 3 is 9. Now another thing I'm going to start skipping, and this one's a little more advanced. Okay. If these two are complex conjugates, what is going to have to happen to my middle two? They're going to cancel. So what's the point in writing them?
Yeah.
Okay.
That's right.
All right. As long as you're sure you have the conjugate and you don't write those middle two, that's fine. Just make sure you don't screw up your next sign, which is 5I times negative 5I. Okay? Just be careful with that, okay? So you got minus 25 I squared. I squares in like terms, so the top one, you got negative 10 minus 6I, becoming plus 25 down at the bottom, so plus 9 gives you 34. And then those all reduced by 2. So negative 5 minus 3I all over 17. Okay, the bottom one you have 1 minus I, so that conjugate is 1 plus I. 1 plus I. What's different about this one? Yeah, you got binomials top and bottom on this one, so you got to FOIL twice now, okay? But no big deal, same process.
That's what I did wrong.
All right.
It was the first thing I did.
So you get 2 plus 2I plus I squared all over 1 minus I squared. Once again, like terms cleaning up. So I squared is -1. So 2 minus 1 gives you 1.
This one,
Plus.
would it be, oh, no.
3I. I squared on the bottom is -1. So 1 minus the -1 becomes 2. Okay. There you go. Page 176. It's a little choppy this time because I wanted to pick and choose, all right? 42, 44, 55, 58 through 62.